you can really build a bad user experience with Ionic. But you can also create a bad experience with any tool. So, in this presentation, you'll take away a few things. So, we'll talk about why Ionic and why our team uses Ionic. We'll also talk about the 80/20 rule of an application, and we'll go through an e-commerce example. If you think about, e-commerce tool, you kind of think maybe they're all created equal, but when you really think about the users, that might not be the case. We'll also go through the benefits of an event-based architecture. So if you haven't used an event-based architecture before, you might find this pretty interesting. And then we will also talk in depth around the client-side architecture and maybe some new things that you haven't played around with. Towards the end, we'll get to talking about, basically we'll sum it all up into basically the superpowers that you could provide by a modern-based architecture. We'll go through a lot of performance tips. And then finally, if you're a fan of the Matrix and you didn't know, on December 22nd, there's a new Matrix coming out called Resurrection. So I'm looking forward to that, and hopefully it ends up being good. So who am I? My name is Tom Ingoglia. I'm a husband and father of 3 boys and a little dog, and I am on the architecture leadership team at US Foods. My focus is on enterprise architecture and also technical lead on our customer-facing applications. If you didn't know, US Foods is the second largest food service provider in the United States. And if you eat in a restaurant, there's a good chance that the food delivered there was provided by our company. We're basically all across the United States. And then finally, of course, the disclaimer, the views expressed are my own and not necessarily those of my employer, US Foods. So let's dive right in here. So let's just touch on why Ionic really fast. So there's a big reason why you might want to really consider Ionic over other tools. And it's not because you employ web developers today. It's also not because your team loves React, Angular, or the Vue frameworks. It's not because you could build a native UI on top of web standards, primarily the browser. It's not because you can use languages like HTML, CSS, and JavaScript or TypeScript. It's not because it provides a robust tool set. And finally, it's not because it's free and open source. Ionic equals productivity. So it's really because you could create a best-in-class application across devices with about an 80% code reuse if you really do your architecture right. So there's a risk, of course. We're taking web developers and we want them to be mobile developers. So we need to transform that web developers into mobile developers and thinking about that, right? And your UX team. So just a quick, I'm not going to spend a lot of time here because I'm sure you all have experienced the difference between web and mobile apps, but just, some things that you might think about other than the screen size, obviously, right? So here we're showing a desktop app, we're showing a tablet app, and we're showing a mobile app. Of course, the 3 screen sizes you need to account for, but also the layout and how you present things to the user might end up being different based on that screen size, and also based on how you use the device, using a touch versus a mouse. So, enter in a quantity, for example, of how many you want to buy. It's easy to type on a keyboard, but once you want to use the little touchscreen, that doesn't work out too well. So you might think about using something like a plus or minus for users to add something to their shopping cart. So just little things like that you want to think about. So that's not really what this presentation is about. We're really going to get into deep into some different architecture ideas for you. And so let's dive right in there. So first off, you have to focus on what's important. So really more important than the tools you're using, you really have to understand your users. You need to define your user experience for the specific use case and for the specific device. So don't always think about the use case and how it's going to work. You also think about that use case on a device. Secondly is the 80/20 rule. And of course, you probably know the 80/20 rule really applies to a lot of things in life. But basically, the idea is typically 20% of your effort of something goes into about 80% of your results. So you'll do a lot of work, but not all of that work will really turn into results. 20% of it is about the average. So if you think about developing an application, 20% of your features are probably being used 80% of the time. So think about that, what that tells you, right? Really, you should focus on that 20% of the application and make sure that you're really delivering that first-class user experience. But more important, make sure you understand what that use case is. What is that 20% of your application that's being used 80% of the time? And so what I'd like to do is just walk through a use case of thinking about shopping on Amazon compared to US Foods. Now, of course, restaurants can purchase off of Amazon, and I'm sure they do. But when you think about the use case for our customers, the primary use case versus like Amazon, think of your experience with Amazon. So you'll go to the website, you will probably already have a product in mind you want to buy, and you'll start searching for it, and you'll compare different products, and you'll switch back and forth and look at those and really try to find that product, right? You're looking at the price, and you're looking at a lot of details, and finally, you're setting yourself up for that Christmas experience, right? When Amazon shows up to the door with your product, and you open it up, and yay, I got the product I wanted. So it's really about the search experience when you're using Amazon.com. For restaurant owners, think of that use case. So in that case, you already know what you want to buy, right? You have a menu of products that you prepare for your customers, and you are also a business, right? You're not trying to have fun in ordering. You want to get your order, you want to get in, you want to get out, because maybe people are starting to come in for to order lunch, or maybe it's the end of the day and you want to go home. So it really needs to be a fast experience. So you might think about a shopping list to help your customers with that. Here's all the products that you buy all the time, and maybe even have shopping lists for different parts of the restaurant. Maybe you've got a shopping list for the bar. Maybe you've got a shopping list for the freezer, so you could break that down, and when you're in that area, get to those products pretty fast. Of course, our customers are always looking for new products, and we want to suggest newer, better products. So the search experience is important, but it's not that 20% of the application that our users are using 80% of the time. So the 20% in the Amazon world, 20% of the application, you have to build a really phenomenal search experience, right? In our world, you have to build a really great, fast ordering system from a shopping list. Also, it's when you're thinking about a restaurant, they're not really technically minded typically. They probably don't have a high-speed internet, so you have to think about things like that. Also, you might have a couple people in the restaurant ordering at the same time. So what does that experience look like when you have different people in different parts of the restaurant adding things to the shopping cart at the same time, right? What does that user experience come like? So you could really see we have really two e-commerce applications, but they're really vastly different when you think of the users and what their expectations are coming out of that. So let's think about what we know a little bit for if you're a restaurant, and how you might approach purchasing. So touched on a couple of these a little bit. Again, you probably you're not a tech company with high-speed internet all day long. You probably have a slow DSL. That you don't use the internet all day at the restaurant. So why spend the money on a high-speed internet? So we have to build an application that performs really well without high-speed internet. You also you may be offline. Maybe when you go in the freezer, you're not going to get a good internet connection. But we still need to provide a good experience, right? We still need to be able to filter and sort shopping lists. If you're on your keyboard, you probably would like to do some keyboard shortcuts, so you don't need to go back and forth between your mouse. Again, you want a very, very fast ordering experience. We touched on the shared ordering experience. Maybe someone's out at the bar ordering items, and somebody's in the freezer. Maybe someone's in the kitchen ordering items. So what does that experience look like if multiple users are adding things to the shopping cart? And then the other thing that you have to think about is, if Amazon's out of stock on something, maybe you can come back and get it later, or, browse around and find something else. But when you have a menu that you need to serve up to customers who come in, it's important that you can make those meals over and over again. And so if obviously in the pandemic that we're going through right now, everyone knows that supply chain issues and restaurant ordering patterns have changed, and you really rely on stability of products coming in and being able to do that. So if you can't provide a product for some reason, if our suppliers are out of things, we need to be able to be really good at saying, hey, we're out of stock on this, but here's another thing, another product that'll work out good for you. Again, we want to get you through that process as fast as possible. So really a little bit of a different mindset in many ways that you want to think about. So if you break it down a little bit more, what might this look like? So obviously you need a robust shopping list. Amazon has a good shopping list. You can add things to it, but when you really think about the shopping list that we provide in the food service business, it's really a robust thing, because that's that 20% of the app that users are in there using. We really need to provide a lot of detailed information about products, nutritional information, allergens, all that stuff. And that would be probably the same with Amazon, right? When you buy something on Amazon, you want to know all the different attributes of the product that you're buying. There's also a regional aspect of the products, right? Because some of them might be locally sourced. Different regions might buy different types of products. So in our different divisions, they would typically stock different products that might be more or less popular in certain areas. So we have to think about that part of it. The shared ordering context we talked about, right? So we need to be able to if a user is adding something to the shopping cart, wouldn't it be nice if everybody who was ordering at the time could see that? Live inventory, if we're going to run out of something, we probably want to let you know and lock that order in when you're done, when you're completed ordering. And then think about some of the products we sell that are more like commodities, right? Fruits and vegetables, things go in season, out of season. Sometimes there's shortages on things, and some of the products might fluctuate from a pricing perspective based on that. Then, if you think of, traditional maybe Magento ordering system, right? Typically a store maybe logs into the back end of that, and they look at the orders that they need to fulfill and they ship those out, right? But when you think of a large enterprise, we have 70 or so warehouses around the nation, huge warehouses. And so our team is not actually going into the back end of our system. We have other systems that handle all the that work for all of the fulfillment part of what we need to do, right? So when you think of an e-commerce application for a large enterprise, this is probably true across most large enterprises. We're really doing a lot of integrations. As a matter of fact, with our e-commerce application, we're pretty much the system of record for nothing. So we are always interfacing with other backend systems. As those backend systems change, we need to know what changes are, and we also need to transact through those backend systems. So robust integrations are absolutely vital in what we do. So thinking about all of this, maybe put your architecture hat on a little bit. Where does your head go for architecture, right? So, maybe you have to pick out, the type of application you want to build. Do you take the red pill or the blue pill? Kind of tying back to the matrix that's coming out. So do you want to build a monolith or microservice? You could probably do either. Microservices tend to be great for larger teams. You want to move fast, you want to do frequent deployments, but monoliths tend to be a little bit easier, a little bit less to think about. Relational or document database, again, it really depends on your use case, right? But when you're thinking about the e-commerce tool that we're building, maybe document database makes more sense than a relational database. And then, if you're using Ionic, React or Angular, or maybe Vue, so you have to kind of decide, maybe what the experience of your team is, or what tool you like better. So in our case, we chose microservices. We have a good sized team that works on our e-commerce platform, and it allows us to do more frequent deployments. Document database lends itself very well to the types of data that we have and how we transform data and get it out into our serving layer. And we'll go through this in our application. And then finally, Angular. We love Angular at US Foods. We have a lot of Angular talent. I'm a fan of React, and a lot of people on the team are fans of React too. So they're both really great platforms. Angular tended to align a little bit better with the experience of our team and kind of how our organization functions. So I'll leave it up to you to decide which is the red pill or the blue pill, but that's kind of where we did it. So again, microservices, document database, and Angular is kind of our baseline of what we're using. And then we have built on top of a domain-driven design-based architecture. So we'll talk about that a little bit and what that really means here coming up. So when you're thinking about microservices, you need to break things down into multiple domains. So if you think about some of the domains for an e-commerce application, right, we want to separate these small domains into areas that different teams can focus on. So you've got users, of course, customers. So a restaurant would be considered a customer, and then there might be multiple users in that restaurant, right? So that's how users and customers might break down. You've got product details. You've got orders, right? Users are placing orders. Again, the robust shopping list idea, right? So you have idea of shopping list, inventory, pricing, etc. So let's take like the product domain, for example, and we can kind of look at the architecture around the product domain, and that will maybe help give you a sense for how we think about an event-based architecture. So that would be this diagram here, and I'll walk you through a little bit of what this looks like. One step back, sorry about that. So if you take a look on the bottom here, this is our on-prem, right? So systems that are on-prem, we have some mainframe systems in there. We have an Oracle database in there. We have MySQL databases, large enterprise. We have a lot of different technology depending on, what those systems of records are. On the top, we use AWS in the cloud. So we've got AWS here. We use Kafka for our event-based architecture, so Confluent Cloud. And then over on the right here, MongoDB Atlas. So we use the managed service of MongoDB. Great tools, both. And then our services are built inside of on top of Kubernetes and containers, which is pretty popular today. And so I'll get into the details a little bit on that. And then, of course, we need to be able to store assets, right, for the product images. So S3 is a good architecture for that. Of course, you could put a firewall out in front of it, and you can use CloudFront for doing your CDN. So that works out great. So let's talk a little bit about what we're really trying to get to, right? So we have our client application coming in from the cloud. Of course, if we're looking at a product detail, we need to get some assets, and we'll talk about this in a minute. But you also need to go into the application through some kind of ingress and hit some kind of API, right? So in this case here, we have our product API that we want to hit, and it goes out to our MongoDB and looks for the document that you request. Maybe you request 10 products because you're showing it on a shopping list, or maybe you request one product because you want to view the product details, right? So we have a very simple transaction when that happens. Basically, we're going through saying, hey, API, give me this product. Since we are in a document database, you don't want to think of it as a relational database and joining a bunch of documents together, right? You want to basically have those documents pre-built out. We'll talk about that in a minute. We are using Node as our and TypeScript as our service language here where we're coming in, and so if you could think about this, MongoDB is hugely scalable. We could scale across different regions in AWS if we want. If you think about Kubernetes, we could spin up many, many containers, so we can really scale this level dramatically. And there's not a lot to break in the middle, right? As long as we keep that database up and running and we keep our microservices up and running, we could fill those requests really, really, really fast and scale that. But we have to get the data out there, right? So in our backend system on-prem, we have our product information management system, right, which we said has a Microsoft SQL Server database. We have our divisional data inside of an Oracle database. So divisional data. So that's basically, if you think of a product from a global perspective, right, can of beans, that can of beans is going to be in multiple divisions. And maybe it's not sold in some divisions and it's sold in other divisions. Or maybe the supplier in one division is different than a supplier in another division. So there's a divisional aspect of that. So we need to tie both of these together to ultimately build that document so we know about that product, we know where it is, where it's sold, what the inventory is, and all of that. And so that's where Kafka comes in, using some Kafka connectors. So the idea is that basically we have these databases on-prem that can be changing all day long, right? Maybe we have some updates to products or the divisional data. The idea behind Kafka connectors, you are going in and you're looking at these databases from a change data capture perspective. So when something changes in any of these databases that we care about, we need to know about that, because the goal is to say something happened and we need to get that out into our serving database. So we have a Kafka connector that would connect to the two different systems here, watching for those. Then we come into our Kafka layer, and so these would be Kafka topics that are listening for those changes. And we have microservices that are listening for those changes, because they may have to do something, right? So for example, if we're listening for changes that are happening on images inside of our PIM, Product Information Management System, we may have to go and grab a new image resource from our asset source and publish that image out into our CDN. So we have a service that basically just says, if there's an image that's updated, I'm going to create all the different variations of that image, and I'm going to drop that out there so that can be served up. When we do that, we also have to let the document know that there's images out there and where that could find that image, right? So we need to basically do a couple things. Also, if product data changes, let's say an attribute changes in one of the products, we need to be able to listen for that. We need to transform relational data that's coming in, right, because these are relational databases, into a document database. So that's what's going to help us here by going through this Java code to actually, take those different related tables and turn that into a document. And then we also need to bring in the notion of the divisional data. So that's what's happening here as well. So ultimately, what's coming out is we have these documents that do a great job of describing products coming from different systems, and we really simplify the architecture in terms of from the client perspective. But since this is all event-driven, we really get some neat things happening here. So if you think of maybe a traditional enterprise where you do ETL, often maybe you'll do an ETL every night on the database, and you'll move that out into the cloud and serve from that. But those changes would happen every night when that process runs. In this case here, these changes can happen all day long, and they do. So we have real-time data that's sitting out here into our MongoDB that we serve from. So what's interesting is when you think about that from the order perspective, or you think about that from from an inventory perspective, we can capture what's happening in our systems real time for inventory and actually know when that client actually goes to grab that product, exactly what the inventory quantity is on that. Matter of fact, since it's an event, we could even say, if this user is online who cares about this product, we could actually update the inventory on the client side based on that happening. So it really gives the whole event idea really provides a lot of superpowers to tie back to that to our application, to our UX team. The UX team says, wouldn't it be great to be able to be on a page, and if something runs out of stock, let the user know before they actually submit their order. Or if there's multiple users adding to an order, wouldn't it be great for the total to update for the application, even though both users might be placing that order? So you really get some neat things out of that. So I won't go through all the domains, of course, but this is an example of what a product domain might look like, and then this pattern would be common. Of course, different systems in the backend that we would connect to, but would be common across all of those domains. So let's pull it all together. One thing I didn't mention too much is our domain APIs are very unopinionated. So when you think about building APIs, REST APIs or whatever, typically you find yourself gravitating towards, well, I need to return the data that looks like this so I can data bind it on the client. We end up building all these very opinionated APIs, which might make it easy to build the client-side application. But on the other side, are they really reusable? So, one of the goals behind APIs is so you can, reuse it. If you think about a large enterprise, there's a lot of pieces in the enterprise that really care about product details. For example, we have to feed that data to our search engine, right? So there, and different teams around the organization that care about that product data. So if it's unopinionated, that's great, because we don't really need to think about all those downstream consumers. They can form their own opinion on what that data is like that looks like. So the second thing here is we want to build very clean and testable abstractions. So if you noticed on the previous slide, we really separate out the idea behind the integration services and the domain services. So one team's kind of working on those integration services, and you're just wearing that hat when you're thinking about the integration services, right? Performance of getting that data in. You're not thinking about how to serve the data out of the integration layer, right? And same with the domain services. You're figuring out how to get into that database, get your data, get out as fast as you can. So you get to kind of put on a different hat, and you get to test those things individually. And also, if you think about it from a REST perspective, your testing is going to look different than an event-based testing, right? So you really need to separate those two ideas. Then there's also the idea of shared services, right? Like a login, for example, might be a shared service or a logging service or something like that. And then we break down a few other different abstractions. So we talked about the opinionated versus unopinionated. So we might have a domain abstraction that basically says, here's what the data looks like on the server when you get it. But then when you start to get the data down into the client application, now you want to look at that data from a different perspective, right? If you're using state management, for example, you may have a presentation of that data in state, and then you say, I need to build this UI, so now you need a view model of that data that's in there. We're going to walk through that in a coming slide on that, so you can see how that architecture aligns on the client. And then finally, you have a display abstraction, right? So you have a web view, you have a tablet view, you have a mobile view. If you can keep that display abstraction simple, not have a lot of code in it, that's where you start to get your 80% code reuse, right? Because your state management, your view model could even probably be pretty close. When it gets down to that display, that's going to be the 20% of where you say, I'm going to put the mobile hat on, I'm going to put the tablet hat on, or I'm going to put the web hat on, and build those UIs as a first-class UI for that device that you're trying to target. So you really want to abstract that out as much as you can. So superpower number one we talked about, right? And so this is the idea of real-time events. Gives you a different way to think about architecture, right? Rather than saying, I have to go get some data from the organization, and how do I drill in and go into this database and that database and pull that all out into a view, you have the mindset of thinking about what's changing. This event happened in the organization, and as a result, I have to do something. An image was added to a product. I have to do something. I have to take it from our private repository and put it out in the public repository. An attribute changed. I have to take that and I have to put that into a database so I can serve that out. So again, the different way of thinking about it, and then also the superpowers you get, right? Product changes, inventory changes, order changes. We can let the user know in real time that that's happening with an event-based architecture. So we can actually deliver an experience where two users can be ordering at one time, and you can be watching that total change as those users are adding items to their cart. Superpower number two is reusable API. So think about the unopinionated domain model versus an opinionated view model. If you're doing things right and you're doing your architecture right, you could create that view model on the client side, really separate that out from the domain model. So this gives you a lot of reusability. So, how does that translate into a user experience? Maybe not directly, but it allows you to iterate a lot faster, right? When you have these systems that can be built and built faster and have a lot of reusable code. Performance. So this one's kind of interesting, right? So if we talked about the simplicity of coming in through a very simple web service, going to a document database, returning that document out. There's not a lot that's happening there. So you can get in and out in 20, 30 milliseconds. Super, super great performance. The heavy lifting is happening when you're getting the data into the database versus when you're getting the data out. So as you think about those events happening, right, we have all these services that are running from an event perspective, but if those are running a little slow, it doesn't necessarily have an effect on the user. Certain ones might, right? From the order perspective, if you want the users to see that order update in real time. But if a product attribute changed, if it took 2 or 3 seconds to get down to the client application before we saw it, probably nobody would even notice, right? So the heavy lifting is really in the integration part as we're transforming that data to get it in there versus trying to transform the data when the user is trying to get the data out, right? provides us a much better user experience and a different way to really think about architecture, even how you do load testing and different things like that. So that would be Superpower 3. So let's get to the fun part now, and that's really Superpowers 4 and 5 that we'll talk about. So let's kind of just recircle back around real quick, just to remind ourselves about the 80/20 use case we have. Unstable networks, right? So we want to build something that's not going to be a real heavy lift on the client in terms of network. We want to be able to do client-side sorting, filtering, and even ordering offline. Again, you go into the freezer and you need to order something, and maybe you don't have good internet in the freezer. You want to still be able to place that order and get through that. Customers are reordering the same products, and this is kind of a key thing in the architecture that I'll get to. But if you think about it, since the customers are reordering the same products, rather than thinking about the product catalog as a whole, when you're thinking about caching, you have a smaller list of items that you can actually cache. Maybe a customer orders 2, 3, 4, 500, or even a couple thousand products. That's not that much data to cache for a user. So if you say this customer cares about these products, you have a nice little cacheable chunk that you could utilize. And we'll talk about this when we get onto the architecture slide. So the list of what they reorder is a reasonable size to think about caching, and even think about client-side caching. And then the other thing to think about is when you're doing caching is great when stuff doesn't change that much, right? So think about product data. How often does a product data change? Very infrequently, right? I mean, you get in there, you put your attributes on and all of that. And so product details don't change a lot. Inventory would change a lot. So maybe you keep those domains separate. So you don't have to always send product data down to the client. You just need to keep the little bits of inventory data flowing. And so you can also think about, building your domains and how you structure your data around how often that data changes, right? So that's kind of a little bit of a takeaway there. So the last thing is Superpower 5 is WebSockets. So it's really taking that idea of events and extending that down to the client. So when you know your client is connected and you want to be listening for events, WebSockets is a great way to do that. So that's how we could basically say an order changed for this customer. Who's online for this customer? Oh, I have 2 users online. Send that order update down to down the WebSocket to the client who's actually connected there. So a little bit of work that you have to do on the back end to kind of be able to do that and keep track of who's online. But again, in that whole event-driven architecture, you have a nice pipeline that you could build for each of those steps. Another thing that's interesting is when we start talking about client-side caching, when you think of a traditional web app, right? You go from one page to another. You load that page up and you say, I need to go get the data. So I'll make a call to the server and I'll pull that data back down and I will show that data in the user interface. So if you think about, if you already have that data cache on the client, you don't need to make that HTTP call, especially if you know you're up to date, because any changes will be coming down the WebSocket. So you know that when you go to the page, you may already have that. So if you think of a shopping list with a couple hundred items on there, you already have that data. And when you first open up the app, you could say, hey, I know the customer cares about these products. Let me just go get anything that's changed for these products before they even get to the shopping list. So by the time they get to the shopping list page, you've already gone to the server. You've already grabbed anything that's updated. So it's another little bit of a takeaway there, right? Rather than saying, go give me all my products, what if you could say, go give me any products that updated? And maybe between yesterday and today, maybe there's no products that updated, or maybe 1 or 2 products that updated. So so you're going back and fetching little pieces of data versus making big heavy requests to the server saying, get me these 300 products, or every time I scroll down the page, go back to the server. Think about how much that reduces the load on the server, right? Because you're really doing some heavy caching on the client. We'll talk about how we do that coming up here. So this gets into kind of the meat of the architecture and how we structure things. So there's a few pieces to this that I'll bring you through on how we think about the client-side architecture. And this will probably be maybe the biggest takeaway that you have from the presentation of really how we think of the different layers and we think of the data. So let me just kind of just run through these sections a little bit just so you can kind of get oriented. Just so you know, the technology we're using, of course, Ionic. We're using Angular. Angular, of course, makes RxJS kind of a first-class citizen, so we really embrace RxJS. If you're using Angular and not, strong with RxJS, highly recommend that you do. And then NGRX is a really great state management library, and of course, it embraces RxJS. So if you can master these three things, you could really do some great things on a client-side architecture. Um, and honestly, one of the reasons I actually like Angular a lot is just because of the NGRX library and the ability to use that inside of Angular and tying it together with RxJS. So we break it down into a few different perspectives, right? So if you look at here, these are just platform services. Maybe some of them are third-party services, some of them are ours, but identity, for example, that's a nice little bundle that you can create. Now, whether you create these as separate node modules that you load in, or whether they're just segmented nice in your application, nice little testable things, that's really depending on, your organization and the app that you're building. Of course, anytime you peel something out into another library, there's, pros and cons of that, right? The pros is it's reusable. The con is it's a little more of a headache to manage. But identity is an example of one. Logging is an example. Tracing, analytics, etc. You see, we have our WebSockets library in here. We have caching in here. I'll get into some of the details on this as we talk through it. Then there's platform components. So components, we think about anything that's got a user interface, right? Maybe status, like a loading status, for example, or the login screen that comes up. These are things that we can reuse across applications, even error handling. We need to present an error to the user. Do we have a reusable way to present that? And then, so these are maybe reusable things, right? Between different applications, your login process is probably going to end up being the same. So that's something nice that you can reuse. And then there are things that are going to be very application specific, right? Like maybe the list tiles that we create or search facets, things like that. And those pieces can actually be, kind of built inside of our application. Then we have these domain services. And if you think about how we talked about on the server side, the domain services, we actually try to build these domain services that marry one-to-one with what's on the server. So user, customer, product, etc. And I'll get into the details of how we really think about these services and how they work. Then you have your state store in the middle. So these aren't necessarily libraries, but this is basically, think of this as the data of how we're storing things, right? We have a state for user data, a state for customer data, product data, etc. I'll get into the meta reducer stuff in a little bit. So we have all our state stuff in the middle. Now, what we ultimately have to get to is we have to build out a UI, right? And this is where, when you're using NGRX, where you'll build something called a selector. And the idea behind the selector, you could think of the selector as a query. So basically, you would say, well, if I need to build out product detail, what do I care about? I don't care about user data for that. I probably don't care about customer data for that, but I do care about product data, right? I do care to show the inventory. I do care to show the price. If I'm looking at a product and I have it in a shopping cart, it would be nice to be able to show that on the product detail that, on this product detail, you actually have 2 in your shopping cart, just so you know. But for product detail, shopping lists probably wouldn't be important, right? But if you're thinking of a list, the shopping list would be important. So if you think about the selector that you want to create, essentially you want to select into your different state to pull that out. And this is where you actually build your view model. So what data do I need to show in here on my UI? And what does that view model look like in order to do that? So essentially, the selector is how you build up that view model. And that's where your RxJS skills and NGRX skills will really come into play. We'll talk about a little bit more about some optimization stuff in a later slide. But essentially, you're querying into your state store, except you're querying in from a reactive perspective. So not only are you querying in, but if anything changes in that state store, it's going to actually fire off your selector again. And if you're data bound to that, you're actually going to see that update live in the UI. So if you think about it, let's say we have our order domain here, right? If this order domain is just thinking, I need to listen to any order things that are changing, This domain, its whole mission in life is just to say, I'm going to update this order state. I don't care who's listening to it. Maybe nobody's listening to it. It doesn't matter. Its whole mission in life is to say, I'm connected to my domain backend. I'm listening to some WebSocket stuff. I am listening to order details, and I'm dropping that into my state. And any selectors that may be bound to that are going to update, and we'll actually see that update. So there's an example where we could say, I'm on my shopping cart page, or I'm looking at my shopping list. I can actually see my order change real time just by building this architecture and creating these 3 separate slices. The UI doesn't need to think about doing a refresh. The selector doesn't need to think about doing a refresh because it's essentially subscribed to all of these different states. And if something changes here, it will see that change because it's subscribed. From the order detail, it doesn't need to understand the application at all. All it needs to do is say, I have this order data and I want to drop that into my order state. So something else kind of important happens here, and I'm going to get in a little bit more detail in a later slide as well. But the other thing here that happens that's important is we have 3 views of the actual data model. One view is the domain model, and that's what our data looks like on the server, right? That's that unopinionated domain data. The second one is a state model. The domain model may look different than the state model. The state model is essentially, what does it look like when we store it here? It may look exactly the same, and that may be fine, but you do have the ability to transform the domain model into the state model, and I'll talk a little bit in a later slide around why that it might be interesting to do that. And then finally, the view model, right? You'll have a view model for essentially every view that you're creating. So the view model, essentially, you're building up from all the different state that you have here, building that view model, and then ultimately showing it. So it gives you 3 different layers to think about that data, to think about how you test that data, and also to think about when it makes sense to do things. When does it make sense to transform the data, the domain model into the state model? And we'll talk about that. Or how can you be very specific about your view model to where you're building the view model that's ideal for your UI presentation. So now one more layer that we talked about is the ability to save things. So there's really 2 perspectives on state, right? One perspective on state is, let's say you go to this regular search page and you do a search and you return some products. So essentially what you would do is you would go and you would say, go to the server, grab these products, drop it in state. Your results would be a view model that would ultimately be showing your search page, right? But that search won't have a value tomorrow, right? So we don't really need to persist that beyond that session that the user's saying. So maybe every time we do a search, we're dropping that product into a state store, but then it goes away every time. But think of it from those maybe 3 or 4 or 500 products that the customer cares about all the time, right? We want to be able to go to the server, grab those one time, and be able to not have to go back every single time we open up the app. So that's where we use IndexedDB on the client. So the idea is, if we just tell the domain model, hey, product, this user cares about these 300 products. Your whole mission in life is to make sure whenever the application fires up, that we're in sync with those 300 that they care about. And then secondly, listen to any WebSockets that are coming down that have an update to products so you can keep that updated. And by the way, for these products that this customer cares about, or maybe we'll call them my products, save that to IndexedDB. So when you actually get that data down, anytime you make a change into product, you want to tell it, hey, go cache this. So anytime product changes, we cache it and we save it in IndexedDB. We take that whole chunk of state, we write it as one object in IndexedDB. We're not thinking about records and rows and all of that, right? We're just saving that one document in. That way, next time the app loads up, you simply say, go to IndexedDB, grab that chunk of product in state, load it in, go to the server, grab anything that's changed, drop it on top of it, save it back to IndexedDB if it did change, and now that product domain is always in sync. If you do that with all of your domains, when your app first fires up, those domain services just understand their mission. Go grab the latest data, drop it into state, save that state, get any updates, and now we have our now we always have, for the state that we want to save between sessions, right? We always have that latest data. So what we've actually built is a caching mechanism that makes it easy to do that as part of our application. And there's one thing that's kind of interesting if you've used IndexedDB and you're using it kind of heavily, especially if you're writing to it a lot. If you think about the loop that JavaScript runs on, right? It's single-threaded. It's running in this loop. Anytime something happens, it's got to stop that loop to do something. If you're taking some time to do that, like write data out to IndexedDB or read it from IndexedDB, if you have anything happening on your UI at the same time, it's going to be blocked. So think about scrolling. Users scrolling down that list, you're going and you're grabbing data from the server and you're updating your state. They're scrolling down that list. It's going to get chunky as we're going down. It's going to provide a bad user experience. But thankfully, we have web workers. So if you combine the whole idea of caching and writing to IndexedDB, which you can, using a web worker, now you're saving that in a different thread. So you have your thread over here running that's saving things to IndexedDB, and your thread that's over here running where you're actually scrolling up and down in your UI. So the net result is if you do it right, you can actually have a very fluid user experience of when they're scrolling down their list or filtering or whatever they want to be doing, with this other stuff that's happening in the background that could be done through web workers. So web workers is a very powerful tool, and you can do a lot with it. It adds another layer of complexity, but if you kind of abstract that complexity out, once you get to the team that's working on users, customers, product domains, you could really simplify that part of it. So web workers, great. IndexedDB for caching, build out its own caching layer. Another thing with NGRX, which is really cool, is this idea of a meta reducer. If you haven't used it before, essentially you can hook in a meta reducer, and what the meta reducer does is any change that happens to any of your domains, it actually emits out. So you can essentially use that for things that care about the collective of this data. And where your mind might go is if you think about analytics or you think about tracing. From the perspective of an action, right? A user clicks a button. We might want to write some data to analytics so we know what the user is doing, right? Are they adding things to the cart? We want to collect that data so we can build a better user experience in the future by understanding how our users use the tool. Think about tracing. We want to understand when the user clicks that button and it goes to the whole back end, how long did it take to complete that process, right? Is our application performing well? We want to keep track of that. So that's a tracing mechanism. Also, if there is an error, it's great to have that whole trace through your back-end system. And you could say, well, let me search for this user ID. Here's the trace for when the user clicked that button. And yeah, we got an exception somewhere. And now we can kind of trace that down and understand how to troubleshoot that. The meta reducer is a great place to hook that, because you could create off of an action or create an action that says, user click this button, your meta reducer will fire. And as a result, you have the previous state, you have what was changed in the from the action, what data did you actually pass, and what the final state is. So you have everything you need across all of these domains to write whatever you need to write to tracing or analytics. So you can build a little library around that to make it easy for your team to do tracing and analytics using NGRX and that meta reducer. Great pattern to use inside of there. So that kind of lays out the client-side framework, and I'll get into a little bit more detail on some of these in the next slide. But separating your domains separately. These domains don't know about each other, don't care about each other. Matter of fact, you could really reuse these domains that you want in other applications if you have the need for that. They're just focusing on getting that data into state. You then build selectors that are focused on getting that data out of state and building a view for the client. And in NGRX, you actually have some neat performance things that's part of it with caching and memoization on your selectors. Really helps with performance. We'll talk about that on how you build out the selectors a little bit. You might want to build a little bit of an abstraction out so you can call to the backend services. You really don't want to abstract out NGRX specifically. So, we embrace NGRX and RxJS in here. But there is a little bit of a facade opportunity there that you might want to take advantage of. But again, actions should be very specific to the part of the application that you're using. So you don't necessarily want to abstract out, actions as part of a facade. But other pieces you can. You can get creative with that. So let's go and talk about optimization a little bit. So we'll recap some of this, but some of this will be a little bit new. So first thing is persistent versus non-persistent caching. Again, persistent is we are getting the data, we are saving it off to IndexedDB. That way we can reuse that next time. Do you have an opportunity in your app for data that doesn't change very much that you could follow that same pattern? I've showed an example here of when it makes sense with the shopping list data because they have a certain data set, or when it doesn't make sense, maybe showing search results. The view layout, talked about this as well, right? So let's kind of recap on that. Same data model, same code, but a different perspective. Your perspective is going to be a mobile app or a tablet or a web app, right? So we're going to get some code reuse there. Persisting state could be janky, right? Web workers, you want to make sure you use web workers there. Refreshing the page. Haven't talked about this, but you should always be thinking about no matter what the user clicks on as a route, right? A little less important for mobile apps because you don't have the back button, but in a desktop app, the back button is important, right? And if the back button is doing things you don't expect, because some places you have routes, other places you don't, you should have a route for everything. So when the user clicks that back button, they could essentially go back through that experience. So think about that direct route for everything, which makes it nice if you want to link into an app and pull up a product detail or something like that, right? Having that direct route makes sense. Tracing. One of the best things you could do for your application is understand how it's performing for your users. The last thing you want to hear is, hey, customers are saying the app isn't performing well. You need to know the app is performing well before you get that phone call from the customer. So that's where tracing and helping you understand errors that the users may be getting and starting to whittle down that, that list of exceptions that you, that you may be ranking up there due to, some inconsistencies between data or users or whatever. Tracing, build that as a first-class citizen in your app really will provide, it's one of those things like, we'll do it when we get to it. You'll never get to it. And you will probably spend more time trying to figure things out than if you had done it in the beginning. Tracing, very important. And then the rendering part of it, right? The smooth scrolling. So virtual scroll versus infinite. So remember infinite scroll, kind of that, Pinterest idea, right? Where you're just kind of scrolling down the list and it kind of scrolls infinitely. We're not really talking about that. You could decide based on the user experience whether that makes sense for your case or not. But really the whole idea of a virtual scroll. So virtual scroll, the whole reason it exists is really from a performance perspective, right? And this is going to be the case with a native app or the case with a web app. If you load too much data into your view, it's not going to scroll, right? It's just too much data to keep in the rendering state. So a virtual scroll says, let's only put the data in the scroll that the user's seeing, right? We'll still have the whole scroll bar, but the data that's loaded in is just what's loaded. So what happens is as you scroll, we need to build that next chunk real time, right? So this really puts you in a certain mindset when you're thinking about selectors, and we're going to spend a little bit of time on this because if you are using NGRX and you are using virtual scrolls and you really want to create a super fast, great user experience with a complex UI, right? And you remember back to the user, the screenshots that I showed, we don't have simple little list items. There's a lot of complexity in those lists. So when you think of the virtual scroll, there's a few things that happen, and I'm going to walk you through really kind of 3 different ways to think about how you're rendering that data. So the first thing is that we need to touch on is selectors. So the whole idea of a selector is you have to go in to these JSON objects, pull that JSON data out and create a view model. So there's a lot of code running to do that, right? And your knee-jerk reaction is, oh, well, let me just walk through this array, and then I could walk through the next array and the next array. But every time you do that, think of big O notation, right? If you're getting to 100,000 loops by the time you drill down the next record you drill down, your application is just simply not going to perform. You need to try to keep to one or maybe one nested loop at the most, because you want to be able to build that view model out in milliseconds. And you could build a very complex view model in sub 100 milliseconds if you do it right. And that really comes down to kind of native to NGRX is everything needs to be a dictionary. You need to figure out how to do one loop and then find everything in dictionaries that you need to find and pull those in. You could kind of think about it as a relational database, right? I've got my one list of records. I need to go through those list of records, and I need to go to all the join tables and pull those out and load them in. Kind of think of it from that same way. If you're in a scenario where you don't have a dictionary that you can get to the data, build a dictionary so that you can get to the data. One of the most important things that you could do, try to keep one loop in your selector. Maybe you have a second loop that you have to do sometimes if it's a small data set. This could let you get to 10,000 items in your list and 20, 30, 40 milliseconds to run through that loop, pull all that data from the state, and build up a really nice view model. You want to try to do as much as you can in that view model there. So the other thing about that is with NGRX, and state management, it tries to follow this idea of pure functions, right? So a pure function is if you give it the same criteria, it will return your data from a cache perspective. So if it knows with these same arguments coming in, I don't have to do all the calculations again because nothing has changed. In a pure function, nothing can change, right? State management kind of helps us get there. So if nothing can change, you can cache the last result and return that last result in 2 or 3 or 5 or 10 milliseconds versus maybe 200 or 300 milliseconds that it took to originally calculate that out. So when you think about little changes that are happening in state, and whenever that change happens, you got to run that whole state again. If you're running it off of cached, memoized data, you can update state and literally in 10 or 20 milliseconds rebuild that state again because of all the memoization that's happening in there. So you have to think about that when you're building those selectors. And you can actually think about tiering those selectors from what data changes a lot versus what data that doesn't change a lot. If you have data that doesn't change a lot, and it's really hard to calculate, kind of want to have that at the tail end of your selectors, right? So you could essentially kind of nest these selectors where when you're going after that last selector, it's cached most of the time. And so maybe all that heavy lifting took 200 or 300 milliseconds the first time. But if you move off of that view and you come back, you can get to that selector, maybe like from like a filter perspective. Filter would be at the top because the user would change a lot, but figuring out all the product details and attributes and pulling that all together, that would be the same every single time. So think about how you're tiering that and how the memoization is going to help you there. The second part is, where do you do the work? So there's really 3 layers of doing this work. Layer number 1 is the first opportunity you have is when you're going from the domain model to the state model. Maybe there's things you can calculate there because that only happens the first time the data comes in, right? Think about that. If I could take a few values and calculate that and drop that in state because I know that's going to be used downstream, that's a great place to do that. That's what you want to transform from your domain state to your domain model to your state model. So now you have state model that's maybe improved a little bit. Maybe some things are materialized in there. The next part is a selector, right? This is where most of your code is going to happen. So that's that second layer. The third layer is rendering. So work will also happen on rendering. So think about that, right? When you scroll down and you move to another chunk, it has to figure that out, right? We have to show something on there. What's the inventory quantity on it? What's the price on it? All of this data, it's in our selector, But how much work do we have to actually do to show it on the screen? The more work you have to do to show it on the screen, the slower the scrolling is going to be. So whatever work you could do inside of that selector and not have a lot of logic when you're rendering, less important if you're like on a product detail page versus on a list page. But when you're on the list page, every single thing that you have to do to build out those list items, agonize over it. Do you have to do it there? Or can you do it in the selector? If you do need to do it there, there's things that you could use, like using pipes, for example. Pipes are memoized. So if it's got to reach out and do a little function, a little calculation, if you can use a pipe to do that, it'll be memoized, and that will improve your speed. So think of those three things. If I could transform at the beginning of time, that's great. If I could do it in the selector, that's the second best. If I could tier it the right way, that helps out. And then do as little as possible in your views. The more logic you put in there to build those, the more it's going to slow down. Keeping those things in mind are really gonna help you out. So what else? I think we're probably running short on time, so I'm gonna just kind of plow through this real quick. So GitOps discipline, observability, OpenTelemetry is a great tool. Event-based architectures solves a lot of technical challenges, but it also introduces some technical challenges. So you really have to think about your data, how to keep all that organized. Unit integration, performance, end-to-end testing, of course, kind of goes without saying. Our tech stack, basically we're using Ionic, Angular, TypeScript, and Ionic AppFlow. Nginx talked about that. Testing, if you haven't used Wallaby before, it's a great test runner that integrates with other testing libraries. Cypress is a great UI testing framework we're using. And then backend services, AWS, Kubernetes, Java, Node, Confluent Cloud, MongoDB, New Relic is kind of our stack there. And then Confluent Cloud and MongoDB have really been great managed offerings for us. Recap, Ionic provides a great user experience on all devices. Consider the 80-20 rule for users, right? What does that look like for your specific users? All e-commerce applications aren't the same, as we've learned. Architect those clear and testable abstractions. Event-based design, as you can see, really provides a lot of superpower. So you can take that whole event model all the way through. So your team can think in events at every layer. Client-side caching, very powerful if you can get there, especially for mobile apps. And then high-performing apps take work on any platform. So as we talked about the selectors and tiering it and all of that, no matter if you're on Ionic or web or whatever, native applications, it takes work to build a high-performing application. So just because you get the feature done doesn't mean you're done from a performance perspective. Iterate on it. You don't have to solve it all at one time. You get it working. That's step one. Step two is, how do we improve it? Iterate on that over a couple sprints, and you'll get to a great performance level. Consider an 80-20 rule. What superpowers can you bring to your UX team? I will be around a little bit for questions. I know we went a little bit over, so I'll stay a little bit longer and answer any questions that you may have. Appreciate you taking the time. Thank you.